We're going to span the range from the very fundamentals of electricity and magnetism all the way to a very practical application. It's kind of fun toy here. So we're going to end up here, but we're going to start over here. It is a law of electromagnetism that whenever you have a moving charge or a current, that will create a magnetic field. And as shown in this little slide here, that magnetic field sort of loops around. So if you put your thumb in the direction of the charge moving or the current, you're going to a magnetic field that's going to loop around that. And so that's what we have here. I have a battery that's basically just hooked up to a wire, this heavy pipe. Not heavy, but anyway, and I'm going to drive a current through it that way. And if the current is going that way, then that should mean that we're going to get a magnetic field that is going to loop around this way. In order to demonstrate that, we have two compasses, one above the needle, one above the thing, and one below. And so we should see that the red, which is indicating which way the magnetic field is going, that's going to effectively wrap around. So if we just look at the compass needles, when I push the button, the top one is going this way, and the bottom one is going this way. So the magnetic field is looping around, just as we said, in the direction of my fingers when the current's going in the direction of my thumb. That was kind of a reciprocal relationship. So in this case, we just saw that if we have a moving charge that makes a magnetic field, if we take a moving charge and we put it in a magnetic field, it turns out it'll get a force. And that's called the Lorentz force. And it's given by the kind of a strange formula that it depends on the current that we have or the charge that we have moving, and also how fast it's moving and the strength of the magnetic field that it's in. But the force is always at a kick to the side. It's always a transverse force. And the way to figure out how it goes, you put your fingers in the direction that the charge is moving, and you curl them into the direction of the magnetic field, and your thumb goes in the direction of the force. So what we have in this demonstration here is, again, I have a wire. So first of all, I have a permanent magnet that's making a magnetic field that's going right towards you. And I have a wire that when I run a current through it, the current's going to go this way. So the charges are moving this way. The magnetic field is that way, so we should get a force that's up. And when I push the button and I run the charge through, in fact, that's exactly what happens. The wire is getting this force up. And that force that the wire can get, we use that, for example, in making electric motors. So that's a way that we can apply a torque on a motor and get it to spin, basically by running a current through it when it's in a magnetic field. And then it moves, the charges move, get this lateral force with respect to the magnetic field. So coming back out now over to this first little demo that we had, this is basically the same thing as we had over there, except instead of a thin wire, we have this sheet of aluminum foil. And I'm going to be driving a current, but not just one way. I'm going to be driving a current back and forth. In particular, there's an amplifier that's driving this, and the amplifier is hooked up to this iPod. And what happens when we drive a current going one way is that this aluminum foil is going to get a force upward. And then when we drive the current back the other way, it's going to get a force downward. So the aluminum foil is going to oscillate, and it's going to oscillate at whatever frequencies we send in. So for example, if I send in a little bit of Duke Ellington here, so that's actually this. Here, you can hear from my own microphone. Yeah.
Oh, so that's actually coming from the aluminum.
That is from the aluminum, and if I just touch it, you'll hear that it gets damped out because I'm stopping it. So this is basically like a speaker. We've just made a rudimentary speaker by passing current through this aluminum foil.